A wonderful good morning, ladies and gentlemen. I welcome you here at the Technical Forum at the group exhibit Hydrogen Fuel Cells and Batteries, this year in 2015 at the Hanover Fairground. Every 15 minutes, I'll present you interesting presentations regarding the hydrogen and fuel cell industry. Also, at this time, I would like to say good morning, good afternoon, good night to all our online guests. We are live streaming from the fair, over 25 different countries here, and even more are watching us from all over the world. Our next presentation will regard the use of waste hydrogen, and we'll discuss the Power Up project. And for that, please welcome with me on stage representative of the European Hydrogen Association, Mrs. Marieke Reijalt. Big hands, please.
Thank you. Good morning. Yes, indeed, European Hydrogen Association. We have a stand here, E65, where we present different projects, and we also facilitate presentations of the projects that we support dissemination and communication with. Just quickly on the organization. The European Hydrogen Association is managed by a federation of these type of associations, scientific and technical associations that are pushing forward towards a market for innovative solutions like hydrogen and fuel cells. And the FAST Federation has been managing the offices of the European Hydrogen Association since quite some time. It was founded in 1897. And it operates from Milan, representing 30-something organizations since the 19th century, we can say now. European Hydrogen Association, we started with 6 founding members in 2000. The organization has steadily grown now to 22. Of course, our aim is to get all the 28 national associations represented, but we are broadening the representation fast. It's now Turkey as the last member joining, who also has representation here at the fair. So this is a constant growing community of industry, of research institutes, of local authorities that are pulling together to shape the conditions in their countries to use these applications in the future. So quite a number of companies through these national associations are represented. Well, how do we support these associations? Mostly, of course, also with a lot of information. We are supporting the joint undertaking in the dissemination of these activities, not as a partner, but as an association, of course, with quite a network of contacts. And Power Up is actually one of those more recent stationary fuel cell application projects that probably for a lot of also new member states might provide interesting solutions that our members are picking up and communicate to the right stakeholders in these countries. Power Up at the moment is actually the leading project in Europe on alkaline fuel cell development. It's coordinated by AFC Energy, who has taken up this technology a few years back. And with the Power Up project, we are targeting this market of what is called waste hydrogen or surplus hydrogen from the chloroalkali industry. And the aim with the project is really to install the world's biggest fuel cell system using this type of hydrogen. Well, what is actually indeed happening in these chloralkali plants in relation to fuel cell and hydrogen activities, the waste hydrogen amounts that are produced in these chemical processes is actually quite large. Also, the electricity use in these plants is quite significant. As you can see, it's 1% of the world's electricity consumption. And also, these plants produce with this type of hydrogen an equivalent of 400 million euros of electricity if this waste hydrogen is used per year. So this could amount to 3 gigawatts of generating capacity if all this hydrogen would be used in fuel cells. So the perspective of a market and a business case are quite interesting. Well, according to the review of the Eurochlor Association, the European Chloride Industry Association, actually 12% of the waste hydrogen produced is not used. Of course, these companies are finding usage for this hydrogen as well, but it is an increasing percentage that is actually not used. And that's what the Power Up and the alkaline fuel cells are tapping into. Well, quickly, the Power Up project is a project co-funded by the Joint Undertaking for Fuel Cells and Hydrogen. They also have a stand here at the fair. It's co-financed by, with 6 million euros on a total of 11.5 million. It's a project that will have a duration of quite a number of years. We are working until June 2017, also to valorize the installation and make sure that we have a good data collection of how the system will be operating. And we are currently working towards the installation of the plant already, because this plant has been developed during the project that started in 2013. It's only a small number of partners in this project. There is also a good research support of this, of the Paul Scherrer Institute, to indeed also do a good life cycle analysis of the plant. So far, the project is on schedule. The first milestones have been announced. The building up of the plant, of course, was one of the first challenges in this project, to make sure we could reach the size of this plant required. Just a little bit about the core system. There are 3 major components: the electrodes, the cartridges, and the complete balance of plant. Also here, this is being established as a production facility by AFC Energy at the moment, to indeed, with this project, develop a full production system. It's a 101 cell stack, so quite a number has to be produced, and this is of course referring to already initial improvements in production processes to make the whole production process more efficient. Well, you can see here a little bit the starting of the first smaller systems of 5 kilowatt. In 2012, already 50 kilowatts was possible, manufactured by AFC Energy in the UK. And now in 2015, they are finalizing this 250 kilowatt system. 2 of them will actually be used in this first installation. A bit more pictures of the first build-up that is now taking place in the production facilities. Well, the building up of the system, of course, follows different stages. It consists of 3 independent levels then, and each is comprised of 8 fuel cell cartridges that each produce 10 kilowatts of power. Then it can produce continuously as a system. And the only byproduct then is water, referring to this zero emission potential then of the system. And indeed, the 250 core modules will then be installed in a location in Stade here in Germany, actually quite close to Hanover. Well, the manufacturing, the electrode manufacturing process is indeed an innovative process that was developed by AFC Energy to speed up and to also cost efficiently produce the stacks. This facility is now fully operational, and during the project this production process will be further optimized. So this is a bit on the location that has been selected close to an Air Products, to an chloralkali plant here in Stade, where Air Products has its operations. So the location will be at their site and in Stade. Well, the ground digging was actually indeed breaking grounds yesterday already, so you see the latest status of this installation preparation. A quick word on the Strategic Advisory Board, because of course with such projects the input of industry experts, but also even more importantly authorization officials that in the future will be dealing with the authorization of these installations. In most of the hydrogen and fuel cell demonstration projects, we know that authorization is really a process that has to be prepared carefully and intensively with authorization officials. So we hope that within a strategic advisory board that is currently being established in the project to further have insight and very up-close insight and possibilities to look into how the installation has been built up, how the system is being built up, how the installation is taking place, is currently indeed selecting experts in joining this effort. So we would really encourage you to let us know of your own or maybe colleagues' interest to become part of this, because I think these kind of projects and more projects in the joint undertaking for fuel cells and hydrogen are offering this opportunity to be really informed well and have close-up insight in these installations. So please contact my colleague Ahmed Ali. He's sitting over here. If you have a preliminary interest, that would be appreciated. We also have an AFC Energy colleague here. Chris Reijalt is here for all your questions on a more technical level after the presentation. Thank you very much.
Thank you very much also from my side. Are there any questions from the audience at this time? Yeah, it's almost noon. I expected more people to be awake at this time.
One question about the type of electrolyze of hydrogen used. Okay, you mentioned alkaline cells. There are now technology offer PEM. So why you decided alkaline cells and not PEM? Is there any difference? Advantage, pros and cons for each type?
Yes. Maybe you could give the phone to Mr. Reynolds, because I think he is the most appropriate person to answer your question.
Mr. Reynolds?
Thank you. Hi there. So in answer to your question, alkaline fuel cells are the most, at least in theory, chemically efficient at converting hydrogen into electricity. And because we are not a spin-out company from any university, we were started by an entrepreneur, we could freely choose which fuel cell to go with, and we chose alkaline. It was a little bit before I joined, but that was the decision process. The other advantage is we use a liquid electrolyte, so we not only use it as a part of the electrochemical process, we also use it as a heat exchange media. Therefore, a lot of the challenges from PEM, other fuel cell types, are mitigated by the fact that you can simply use more conventional heat exchangers. You can take the problem elsewhere and deal with it in a traditional engineering way. So, sure. So to answer your question, your question was despite the difference in output, yes? Yeah. Because we are in the industrial setting, we don't have any of the same constraints of volumetric power density that, for example, automotive, other things, other fuel cells face. We can have large stacks. You saw in the presentation. Well, conveniently, there's one on the screen. Our stacks are very large. They're very heavy. They're made to be low power density. We can use low cost manufacturing techniques. We use injection molding. We have simple rubber seals. The low power density is taken into consideration in the design process.
Thank you very much. Are there any other questions from the audience? All right, then I thank you very much for your participation, for your really interesting presentations. For further questions, you two can be visited, or you three can be visited at booth number E65. Once again, thank you very much, and big hands, please. We will now have a break, and here in the technical forum at the group exhibit Hydrogen Fuel Cells and Batteries, we'll come back here at 1:40, and our presentation at 1:40 will be the Spectra car porous graphite materials for specific electrochemical applications. And for that, we'll hear the engineered